Making sense of algebraic fractions. In this lesson we'll look at cancelling algebraic fractions, multiplying and dividing them, adding and subtracting them. Think of a number, multiply it by 2, now divided by 2, and of course you're back to your starting number, because multiplying by 2 and dividing by 2 will cancel each other out. If we let the starting number be represented by n, then we have 2 times n divided by 2, and the 2 times and the divide by 2 will cancel each other out, leaving us with just n. We can simplify this expression by cancelling down. Writing in factored form, 21 is 7 times 3, x squared is x times x, and we've got a times y. And in the denominator we have 7 times x times y. We're multiplying by all the numbers in the numerator and dividing by the numbers in the denominator. So multiplying by 7 and then dividing by 7 will cancel out. One of the x's will cancel out and the y's cancel out, leaving us with 3x. In this example, we'll multiply two algebraic fractions. Now we use the same idea of cancelling out. We can see that the 3 goes into the 12 4 times. The 5 can cancel out with a 5 there. X will go into x squared x times, and y will go into y cubed y squared times. So that'll give us 4x in the numerator and a y squared in the denominator. Let's now divide algebraic fractions. So to divide by a fraction, we multiply by the reciprocal. If we look at that last example again, but we'll write it now as a divide by a 3x over 5y. And so to work that out, we just simply change that to a multiply by the reciprocal of that last term. So it becomes 5y over 3x. And we proceed as we did before to get our answer of 4x over y squared. We look for a common factor to cancel out. So in this example here we have 15a plus 9 over 3, and we'll notice that 3 is a common factor between the 9 and the 15. So we'll take that out so it can cancel out with the 3 in the denominator. And that leaves us with a 5a plus 3. In this example we are multiplying two algebraic fractions. We do this by factorising and then cancelling down any common factors. 2x plus 6 has a common factor of 2, leaving us with x plus 3 in the brackets. 4x plus 20 factorises into 4 times x plus 5. 3x squared plus 15x has a common factor of 3 and x, that is 3x, leaving us with x plus 5. And x plus 3 does not have a common factor at all. Now we can try cancelling down any common terms. X plus 3 can cancel down their common, and x plus 5 can cancel down as well. We can also cancel 2 and 4, and that leaves us with 3x in the numerator and 2 in the denominator. To add and subtract fractions, we need to find a common denominator. In this example, we have two different denominators, and we need to combine them into one common denominator. We do that by multiplying those two denominators. So the first fraction, 3 over x minus 3, is multiplied by x plus 1 over x plus 1. Which of course is equal to 1, so we're not changing the value of that fraction at all. And likewise the second fraction, 2 over x plus 1, has to be multiplied by x minus 3 over x minus 3. We can expand the first bracket to get 3x plus 3, and in the second bracket we're multiplying minus 2 times x to get minus 2x, and minus 2 times 3 will give us plus 6. We can combine like terms. 3x minus 2x will give us 1x, and 3 plus 6 is 9. So we've seen that we can cancel across numerators and denominators. That's called simplifying, because that means that we're cancelling out a multiplication and a division. We have to factorise first before we cancel. And to divide by a fraction, we multiply by the reciprocal. To add or subtract fractions, we firstly have to find a common denominator.